Hello folks, in this video we are going to talk about, and I'm going to do some examples for you on confidence intervals for the difference of proportions. What I'm hoping that you'll see throughout the video is that a lot of this stuff you already know, you've already seen, it's just we're going to have to do double duty in a couple of places because we're dealing with two populations or two treatments from an experiment rather than just dealing with one. Okay, so if we don't know the true proportions for two different populations, right, and we're trying to find the difference between those two populations, if we don't know them, then we're going to use the statistic p hat 1 minus p hat 2 in order to estimate them. Very similar to how if you don't know the proportion p, then you use just p hat to estimate it. Okay, so the general formula, even though we're dealing with a difference of proportions here, the general formula for a confidence interval stays the same. Okay, it's still the statistic plus or minus, and I gotta leave myself some space so I can write the plus minus symbol. So it's the statistic plus or minus the critical value times your standard deviation. Okay, let me throw my plus minus symbol in here. Oops. Wrong font, hold on. Or wrong color, plus minus, okay? And shocker, the conditions that you're used to are also still the same, okay? So you still have to check that you have a simple random sample stated in the problem for both populations. Okay, so that's the difference. You have to check each condition twice, essentially, okay? So randomness, 10%, which remember that is that your sample can be no more than 10% of the whole population. So remember the way we check that is we do 10 times the sample size and ask, is that less than the total in population number 1? And then we're going to do the exact same thing for population number 2. Okay, and then the last one is success, fail, or large counts, which again, we kind of talked about in the previous video when we were talking about the sampling distribution of the difference of proportions. But remember, when we're doing a confidence interval, we don't know P1 and P2. We don't know them, right? That's the point. So because we don't know them, we have to estimate using our P hat values. So what we have here is N1, and then this is going to be P hat 1. Give me just a moment because I have to draw that in. So N1 P hat 1 has to be greater than 10, and then N1 1 minus P hat 1 has to be greater than 10. Okay, so that's for population number 1. Right, and then we have the same thing for population number 2. So I'm going to change all of my subscripts here from 1 to 2. And then I need to make sure that I add that we're dealing with P hat 1 and P hat 2. Okay, because we don't know the true proportions, right? That's the whole point of a confidence interval, that we don't know the true proportions, so we have to estimate them using our sample proportions, okay? So same conditions that you're used to checking, okay? All right, and then the procedure is exactly the same steps. You're still using this same acronym, PANIC. So just as a reminder, P stands for parameter, okay? A stands for assumption, N stands for name the interval, I stands for interval, and C stands for conclusion and context. Okay, so what you see on the left side of your screen and what I'm going to rewrite for you on the right side of the screen is the full formula for the difference of proportions confidence interval, okay? So you have the statistic, which is P hat 1 minus P hat 2, okay, plus or minus Z star, that's my critical value, times square root of p hat 1, 1 minus p hat 1 over n1 plus p hat 2, 1 minus p hat 2 over n2. Okay, so just as a reminder, okay, this right here is your statistic. Okay, this Z star is your critical value. Which remember you get from the Z table. So that critical value is the Z value that corresponds to the middle, like 95%, for example, of a normal distribution, or the middle 90%, right? Whatever your confidence level is. Okay, and then we have our long formula here for, technically, this is standard error because we're using p hat instead of p, okay? But the formula is basically the same, right, as what you're used to. It's just you're plugging in your sample values for each population into the general formula that you already know, rather than using the true values, because we don't know them. All right, so let's do an example, okay? So in this scenario, we're talking about the difference between teens and adults and their use of social media and the internet. Okay, so here's the scenario. As part of the Pew Internet and American Life Project, researchers conducted 2 surveys in 2012. The first survey asked a random sample of 799, that's going to be important, U.S. teens about their use of social media. A second survey posed similar questions to a random sample of 2,253 adults. In these 2 studies, 80% of teens, so that's my true value, not my true value, sorry, these are my sample proportions, right? Because we're talking about within the 2 studies. So 80% of teens and then 69% of adults used social networking sites. So the question here is to construct and interpret a 95% confidence interval for the difference of proportions of teens and adults that use social media, okay? So let's go ahead and go through our 5 steps. Remember, P stands for parameter. So the parameter is just what we're examining. And often they're going to give you exactly what this is in the problem, like usually in the last sentence. So here I wrote examining on here, but you could say estimating the true difference of proportions of teens. And then I'm going to label that for myself. So teens, I'm going to label P sub T, and adults, which I'm going to label P sub A, that use social media. Okay, and if you'll notice, they wrote that out for you right here. You just had to make sure that you included the notation for each one, okay? All right, so let's move on to the next step, which is A, which is our assumptions, okay? And they told us that it was a random sample for both of these populations. So I would just say there was an SRS stated in the problem for both populations, okay? All right, next I have to check, is my population larger than 10 times the sample? So for teens, right, I'm doing 10 times the sample size, which is 799, right? And that is 7,990, and that's definitely less than the total number of US teens, right? That's less than the total number of US teens like in the city of Las Vegas, right? And then I'm going to do the same thing for the adults. Okay, so 10 times their sample size, which is much larger, 2,253. Okay, so that's 22,530. But again, definitely less than the total number of US adults. Okay, and then lastly, I have my large enough sample, right? So that's my success fail condition. So for teens, I'm doing my sample size times my sample proportion. So for teens, that was 0.8. Okay, so that is 639.2, which is definitely greater than 10. So that's my number of successes. And then I'm going to do the same thing for number of failures. And obviously, because these sample sizes are so large, like both the teens and the adults, their sample size is so large that obviously this condition is going to pass, right? But you still have to work it out and show that it's going to pass, all right? So for my adults, my number of successes is my sample size, 2,253, times my sample proportion, which is this guy right here, okay? So that's 0.69. And I'm going to multiply that out, and I get 1,555. Definitely greater than 10. Okay, and then same thing here for the number of failures. 2253 times 0.31, which is 698. Definitely greater than 10. Oops. Okay, so I've checked my 3 conditions. Okay, next is to name the interval. Okay, so remember, you have to kind of go through and ask yourself a series of questions, okay, which is first, how many samples are you dealing with? Well, we're dealing with 2. Okay, is this means or proportions? And this is proportions, so 2 proportion. Z or T, since we're dealing with proportions, this is Z. And then is this a test or an interval? And obviously this is an interval. Right, so the name of this interval is the 2 proportion Z interval. Okay. All right, so that's like our prep step, okay? And this right here is where the actual math occurs, okay? So we need to write out what all of our sample proportions are, write out what our Z star value is going to be, calculate our standard deviation, and then we're gonna write our interval in plus minus form and in interval form, okay? So my sample proportion for teens was 0.8. My sample size for teens is 799. For adults, the proportion is 0.69, and the sample size is 2,253. Okay, so in order to get my statistic, right, my statistic is teens minus adults, okay, which is what I did here, right? We're talking about the difference from teens and adults, so we're gonna do teens minus adults, okay? So that value is 0.8 minus 0.69, which is 0.11, okay? And I'm gonna put a box around this guy because I'm gonna need it for my final interval, okay? Because we have a lot of numbers going on here, usually when I get to the end and of a part and I'm going, okay, that is going to go directly into my interval, I put a little box around it or like circle it just for me so that I can keep track of it a little better. Okay. All right. So next. Okay. So next we need our Z star value, our critical value, right? And we're talking about a 95% confidence interval. So the Z star value always for 95% is 1.96, right? For my 95% confidence level, okay? So I am gonna need 1.96 in my interval. So I'm putting a little box around that for myself, okay? And then the last thing I need is my standard deviation, which is kind of long, right? It takes a while to calculate, okay? But it's 0.8 times 0.2 divided by my sample size, which is 799. So that's for teens. And then I'm going to do the same thing for the adults. 0.69 times 0.31 divided by 2,253. So that's for my adults. I'm going to plug all that into my calculator, and when I do, I get 0.0172. So that's the last bit that I need for my actual interval, okay? So my interval is 0.11 plus or minus 1.96 times 0.0172. Okay, so if I multiply 1.96 and my standard deviation together, I get 0.11 plus or minus 0.0337. Okay, so that is plus minus form, right? And then in interval form, I'm actually going to add and subtract, right? When you add the standard deviation, that is your upper bound. When you subtract the standard deviation, that is your lower bound. So my lower bound is 0.0763. Hold on. Okay, and then my upper bound is 0.1437. Okay, so you can kind of see where these three little things that I have boxed, where they end up. Right, the 0.11 ends up here, the 1.96 ends up here, and then my standard deviation ends up here. Okay, and these are my two forms over here. All right, then my very last part here is my conclusion and context, which that's where you go back to your script, go back to your word formula, okay, which is we are, insert confidence level here, so 95% confident that the interval, you can either write it the way I did here and just like write the interval in its parentheses, okay, that works, or you could say the interval from and then type your lower and upper bound. So from 0.0763 to 0.1437 captures the true, and then just write out exactly what you wrote for the proportion part, or for the parameter part. That's part of the reason why I have to write the parameter part out. Okay, so we are 95% confident that the interval from that lower bound to that upper bound captures the true difference of proportions of teens and adults that use social media. Okay, so now I have one last little question here, which says a newspaper claims the difference between the percentage of teens and adults is 10%. Okay, and the question is that claim plausible? Right, and I would say, well, yes, it is. Right, so yes, because 10% is in our confidence interval. Okay. Remember, the entire point of constructing a confidence interval is to give us a range of possible true values of whatever your parameter is, right? So any number in that interval, any proportion in that interval is a possibility for the truth, right? And 10% is in that interval, right? Which means that it is possible that that is true, right? We can't verify it for sure, right? But we can say it's a plausible claim, okay? Now, another common thing that is asked is, does your interval provide convincing evidence? Here, and I'm going to type this out. So bonus question, does the interval provide sufficient evidence of a difference in these populations. Okay, and the answer here is yes. Okay, and here's why. Because 0% is not in our interval. Okay, so if 0% is in your interval, then that means that the value of having no difference is a possibility for the truth, right? So we wouldn't be able to say one way or the other if there actually was a difference between these two populations, okay? And obviously, because all of the values in our interval are positive, right, then that means we have reason to believe that teens use social media more than adults, right? I know you're all very shocked by this, right? But I kind of wrote that out for you right here. Okay, because 0 is not in the interval, we have reason to assume that there is, in fact, a difference between these two groups, okay, right? And because all of the values in the interval are positive, right? You did teens minus adults, right? So teens use social media more than adults, right? Okay, so there's one other example problem here about President Obama's approval ratings. So I want you all to pause the video here, try this one out, and then check back with me to see how you did. All right, folks, so I rearranged my screen a little bit. Go ahead and check your answers against mine. So the parameter that I'm estimating here is the true difference in proportions of citizens who approve of Obama's job performance in 2012 and 2013. You could have also written that as like the true proportion or the true difference of proportions in Obama's approval rating, right? You didn't have to use the exact same language that I did. You could have simplified it a little bit, okay? I'm indicating 2012 as P sub 12 and 2013 as P sub 13. Okay, so for my next step, my assumptions, both of these were random samples, right? They stated that in the problem. Now, one thing that's a little different about this problem than the last problem is that the sample size is the same for both. Right? Sample size is the same for both years. So you really only have to show that math once, right? So here I did 10 times the sample size, right? That gives me 15,000, which is definitely less than the total number of US adults. And then you just have to say in both populations or in both 2012 and 2013. So you don't have to do that same, like write out that same formula twice because it's exactly the same number. Okay, but for large enough samples, because my sample proportions are different, you do have to check this twice, right? Once for each population. So in 2012, I have my sample size times my approval rating, which is 0.52. So that's number of successes. And then you can see number of failures on the other side. I also did it for 2013. Obviously, when you have a sample size this large of 1,500, obviously, like all of these numbers are going to be greater than 10, unless your sample proportion is like really, 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 really small. So, all right, so that is my conditions. N stands for name the interval. So again, this is a 2 proportion Z interval, okay? Then my I step is where all the math happens. So my sample proportion for 2012, they gave it to me up here, is 52%. Okay, and then in 2013, it was 46%. Okay, and then they told us that I'm looking at a 90% confidence interval. Okay, so I have my sample proportion for 2012 and 2013. Since we're talking about a change in his approval rating, usually you want to do the newer year minus the older year. So I did 2013 minus 2012 because that can give me a direction for the change as well. Right? Sample size for both is 1,500. And then because I'm dealing with a 90% confidence interval this time, I'm using the Z star value of 1.64. You could have used 1.65, like if you round it differently than I do, that's fine. You'll get essentially the same answer. Okay. So last thing I need to calculate is my standard deviation. So I plugged all of my information into the standard deviation formula and got 0.0182. Okay. All right. So then for my interval, right, remember that I have my proportion, right? That's my statistic, my critical value, 1.64, and then my standard deviation goes right here. Okay, and then I'm just doing some simple algebra in order to simplify. So this right here is your plus minus form, and then this right here is interval form. Okay, so my final interval that I got there, lower bound to upper bound, was negative 0.0899 to negative 0.0371. Now, if you used 1.65 instead of 1.64, your interval is going to be slightly different than mine. That's okay, right? Not a big deal as long as your process is correct. Okay, and then my last step of my procedure here is to write my conclusion in context. So that's where I'm going to bust out my script. We are 90% confident that the interval, and then I included the interval, captures the true difference of proportions of citizens who approve of Obama's job performance. Or you could have just written the true difference in Obama's approval rating from 2012 to 2013. That's the same thing. Okay. Right? And then that last little question there is, based on the interval, is there convincing evidence that his approval rating has changed? Okay, so this is one of those questions where you want to look at, is 0% in the interval? And it's not, right? Obviously, the entire interval is negative, right? Because 0%, which would indicate no change, is not in our interval. Then we do have convincing evidence that his approval rating has changed. We actually have convincing evidence that his approval rating went down from 2012 to 2013 because all of the numbers in your interval are negative. All right, you all. So that is it for this video on confidence intervals for difference of proportions. The last video in this section and the last video in this unit, unless you all want me to make a video for free response problems, is going to be on hypothesis tests for the difference of proportions. So I'll see you in the next video. Bye, everybody.